Look at this paper here. So the first thing we're doing is plotting these 3 points. A's at 1, 0, B's at 1, 3, and C's at 3, 3. Okay, so the original triangle looks like this. Now, we're going to dilate it using a scale factor of 3. So we talked about this yesterday. What do we do in a dilation with that scale factor?
Multiply times 3.
Yes, everything up here gets multiplied by the scale factor of 3. So what is 1 times 3? 3. What is 0 times 3? 0. What is 1 times 3? 3. What is 3 times 3? 9. And so then obviously 3 times 3 is 9. 3 times 3 is 9. So those are going to be our 3 new points. Okay, so 3, 0, 3, 9, and 9, 9. Ready? Looks like that. Okay, on the second one, we're doing like we did yesterday, we did a composition. Okay, so let me plot these points. So we have 5, 8 is A, 9, 8 is B, and 6, 5 is C. So it looks like this. Now, we're going to do well, first of all, the translation, negative 12, negative 10. What's this vector, negative 12, negative 10 going to do?
Move it. Slide it.
Slide it what, specifically? Left 12, down 10. Left 12, down 10. So I'm going to start here at this point and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that point ends up there. Erase all these little marks. And then from there, the shape is going to be the same. So I'm just going to recreate the shape over 1 up 3, over 1, 2, 3 up 1, 2, 3. Should look like this. Okay, so this is the first one. This is the second one. Now the next thing we're going to do is reflect across the line x equals negative 1. Where's the line x equals negative 1?
Going up and down or negative 1.
Okay, good. It's this vertical line going through the x value of negative 1. So this is the line x equals negative 1. Okay, how far is this point away from that line of reflection?
2.
2 units. So since this point is 2 units to the left of the line of reflection, I'm going to take this and flip it 2 units to the right, and that's reflecting it over there. So right here. Okay, this one is 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6. And then this one is 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. Ooh. Yeah. Okay. So that's my third one. Now the last transformation we're going to do in this composition is we're going to do a dilation. Now dilating uses a scale factor of 2. Now remember, when we do a composition, this is a progression. So the one that I'm dilating is the third one, is the purple one here, not the original one. So the one I'm going to dilate is going to be the purple one. So whenever I multiply by 2, I'm not multiplying these by 2 because that's the original one. So I need to find out what the coordinates of these points are real quick. So let's just write that down over here. So what's the coordinates of this point? 1, negative 2. What's the coordinates of this point? 5, negative 2. And then what's the coordinates of this point?
4, negative 5.
4, negative 5. Now I'm dilating by a scale factor of 2. So everything here is going to get multiplied by 2. Okay, so what is 1 times 2?
2.
2, and what is negative 2 times 2?
Negative 4.
Negative 4. Okay, what's 5 times 2?
10.
10. What is negative 2 times 2?
Negative
Negative 4. What is 4 times 2?
8.
8. And then negative 5 times 2?
Negative 10.
Negative 10. So these right here are going to be the points of the dilated triangle. All right, so let's plot those. 2, negative 4. 10, negative 4. Oh, yeah, that's right. And then 8, negative 10. And it should look like that. And that is the fourth one. That's the final one in that composition. Okay, what is an isometry? But remember, we've only talked about this just a little bit. What's an isometry?
ISO.
Okay, so an isometry is a transformation that does not change the shape or size of a figure. Okay, it's a transformation that does not change the shape or size. So, over this week, and I guess even some of last week, we've talked about 4 different transformations, basically. There's been 4 of them. 3 of them are an isometry. 1 of them is not an isometry. So let's talk about the ones that are isometries first. Okay, reflection is an isometry because when you reflect it, you just flip it. But it's still the same shape, still the same size. You don't change any of that. What's another example of an isometry? A translation, good. In a translation, it just slides. But after you slide it, it's still the same shape, still the same size. And then there's one more that we've done that's an isometry. Okay, we'll get to that one in a second. This one wasn't on the warm-up, but we've done it this week. Rotation. There you go. Okay? A rotation. In a rotation, the figure turns, but after you turn it, it's still the same shape, still the same size. So these 3, reflection, translation, rotation, do not change the shape or size. So there's one that we've done that does change one of those. What is it? The dilation. Because the dilation, it doesn't change the shape, still similar, but it changes the size. So a dilation is not an isometry. These 3 are, and then on Monday we'll talk about symmetry and tessellations, which is an example of an isometry because it doesn't change the shape or size. Dilation is the only one of these that we talk about that's not an isometry. Okay, so what we're going to do for the rest of the day is we're going to play a little bit of bingo.